Okay, I will get started. So good afternoon. My name is Hanbong Lee. I'm working at NASA Ames Research Center in Mountain View, California. And I'm a team lead for the UAM Aerospace Services Development Team in the Air Mobility Pathfinder AMP project. I'm also a point of contact for the international collaboration between NASA and Korea Aerospace Research Institute, KARI, on advanced air mobility. So I'm glad to have this great opportunity to introduce what NASA is doing for the urban air mobility at this G3AM global conference. At the same time, I'm very sorry that I cannot attend this event in person. So in this session, I would like to introduce NASA's new project dedicated to the urban air mobility research and development, which is called the Air Mobility Pathfinders, AAMP project that I'm working in right now. Until last year, NASA has run multiple projects related to the urban air mobility, including the Advanced Air Mobility Project's National Campaign Sub-Project and High Density Vertiplex, HDV Sub-Project, and a Air Traffic Management Exploration ATMX project, UAM Aerospace Sub-Project. To get a synergy, NASA decided to integrate these projects, such as resources, test, software, and knowledge into one single project and launched the AMP project last October. Okay, so before providing the overview of the AMP project, let me provide some background and motivation first. So the FAA, Federal Aviation Administration in the United States, has released a couple of documents such as Advanced Air Mobility Implementation Plan and UAM Concept of Operation Version 2 document to provide the vision and guidance to the UAM industry and support the expected growth of UAM operations. To characterize the evolution of the UAM operations, the FAA's UAM CONOPS document described a framework defining the initial, midterm, and mature state operations based on key indicators such as operational tempo, UAM structure, UAM-driven regulatory changes, UAM cooperative operating practices, aircraft automation level, and location of pilot in command. Among these three phases, the AMP project will focus on the midterm operations from this year until 2030. So this chart shows the more details about the technical challenges in each operational state. In the midterm stage, we need to define the cooperative areas like the UAM corridor in the airspace. And UAM operators may have digital communication in the cooperator areas instead of traditional voice comms. In the midterm phase, some flights may be operated within remote pilot, and the demand for the UAM services will increase with several verticals for the takeoff or landing of eVTOL aircraft at the transport hub location around the city. Still, UAM operations may be limited to good weather conditions, but they should have some tools and capabilities for the weather forecast and robust operation against adverse weather conditions. And at this stage, some automation technologies would be used for safe operations. So the AMP project will address these technical challenges and consider extensibility for evolving the required technologies from initial phase to the next stages over the years. So for the advanced air mobility missions, NASA plans to deliver recommended requirements, reference architectures, and validation data to assess the feasibility and applicability of extensible traffic management systems, data exchanges, and operational procedures for safe and scalable AAM operation through the midterm stage. Based on this critical commitment, the AMP project set up a goal to develop and evaluate a reference architecture for safe, secure, and scalable UAM operations that can support the public good and provide benefits to the industry and the public. I believe this project can help emerging aviation market to safely develop an air transportation system that moves people and cargo between places in and around urban area using revolutionary new aircraft like eVTOL. So the AAMP project has two cross-cutting teams, the concept team and system engineering and integration team in the top left. There are two sub-projects, flight operation sub-project and aerospace operation sub-projects as shown on the bottom. So the flight operation sub-project will conduct the actual flight test with emerging eVTOL aircraft succeeding from the national campaign. And aerospace operation sub-project will develop the airspace services and their interfaces and conduct the human-in-the-loop simulations to evaluate new airspace procedures and workload of the air traffic controllers. So within the AAMP project, the cross-cutting teams will deliver a reference architecture and relevant integration requirements. And they will be validated by the two main sub-projects on the bottom based on the actual data from research, development, simulation, and flight test. So from the AAMP project, NASA wants to identify and validate a secure path to accelerate UAM operation at scale by maintaining the same level of safety as conventional airlines flight. So as the major expected outcomes, we expect that we can validate key parts of the FAA UAM CONOPS for midterm operations using various use cases and scenarios as a reference architecture and the system level requirements. We will develop and deliver a set of airspace services and automation prototypes that are needed for the midterm operation, such as PSU, the provider of services for UAM, and demand capacity balancing. Those prototype services will be evaluated through the collaborative simulation with industry partners. Also, the AAMP project will support the demonstration of extensible traffic management XTM concept by applying eVTOL and other types of UAM vehicles, which will support the progression toward the FAA's vision for the info-centric national airspace system. The AAMP project is working to contribute to the UAM operational standards from an early phase. Various technologies will be evaluated through the simulation and flight test to ensure safe progressing from VMC to IMC, as well as from crewed to uncrewed operations. At the same time, we will identify R&D efforts to increase the UAM traffic scale from near-term to mature state operations. The AAMP project had three major thrusts, enabling strong partnership with UAM industry and the community. First, we will develop the UAM concept, use cases, high-level system architecture, and relevant requirements with other government agencies and industry companies. Secondly, the Aerospace Operations Sub-project will develop the UAM airspace services and prototypes, system interfaces, and procedures, and then conduct the validation simulation for the integrated evaluation. Lastly, the Flight Operations Sub-project will establish test methods and conduct the actual flight test to assess the eVTOL aircraft configuration and its operational suitability, as well as the CNS, the communication, navigation, and surveillance, and security infrastructure. So this diagram shows the high-level notion architecture for the UAM airspace system from the FAA CONOPS document. As you can see, the multiple system actors like the UAM operators, UAM vehicle and pilot, vertiport operators, the FAA, supplementary data service provider, SDSP, and the public will actively interact and communicate with each other through the PSU, the provider of services for UAM. My team is developing various aerospace services representing those system actors in the UAM ecosystem, as well as their interfaces for the data communication based on this architecture. So this reference architecture will evolve as the relevant technologies become mature and stakeholders establish common business rules called the cooperative operating practices. This will be NASA's main contribution to the UAM industry. NASA will share our lesson learned from the AMP project's activities and inform the UAM standards. NASA people, including me, are actively participating in the ASTM standards working groups related to the UAM and UTM under the F-38 Committee for the Unmanned Aircraft Systems, UAS. Currently, we are attending bi-weekly meetings to develop an initial standard document for the PSU interoperability. We are also sharing the interface data format for the API, the application programming interfaces for the UAM airspace system with the standard groups. I believe the AMP's evaluations will mature the emerging PSU interoperability standards and other standards as well. NASA actively pursues international collaboration in various aerospace research areas. The AMP project is also doing some international collaboration work on the advanced air mobility. So one of the important foreign agencies for the collaboration is KARI, the Korea Aerospace Research Institute. So NASA and KARI signed an implementing arrangement document in 2022. And this document outlines the collaborative project plan that enables joint efforts between NASA and KARI to leverage any technologies developed at NASA and KARI, as well as to demonstrate the readiness of UAM vehicles and airspace operator systems to provide passenger transport and cargo delivery services under the different operating conditions in an urban environment. So NASA and KARI identified three main tasks, including the AAM National Campaign and KUAM Grand Challenge collaboration, simulation requirements and evolution, and flight demonstration information exchange between AAM National Campaign and KUAM Grand Challenge. Since the AAM National Campaign sub-project was merged into the AMP project, those task scopes and milestones will be redefined by mutual agreement. And as part of this collaboration work, NASA and KARI had a workshop at the Armstrong Flight Research Center in Palmdale, California last November. During this workshop, we shared the achievements from each agency thus far and had productive technical discussions on various topics related to the UAM research, simulation, and flight test demonstration. So NASA also has been collaborating with the German Aerospace Center, DLR, for various topics in the UAM research since 2020. But those collaborations tasks include UAM demand analysis, UAM network design and traffic management, UAM environmental impact study like noise impact analysis, and UAM flight performance evaluation. So currently, the AMP project is finalizing our task and milestone planning. We use a crawl, walk, run approach for the UAM technology development. As the first milestone up to 2026, we will develop initial concept architecture focusing on the strategic conflict management of UAM operations, evaluate the demand capacity balancing feature with multiple operators, sharing the same airspace resources according to ASTM's initial PSU interoperability standard, develop the live virtual constructive AVC simulation and live flight environments, and collect the eVTOL vehicle data to validate the UAM operation procedures. So I believe this is my last slide for the AMP project overview. So thank you for your attention, and I wish the great success on this launching ceremony and global conference as well as promising achievement from the Global Association for Advanced Air Mobility in the future. Thank you.